Ah, yes, it's time for predicted y values. Just what you wanted to see, a calculator. All right, let's talk a little bit about how we predict a y variable or predict an outcome in multiple regression. So we're going to end up using a nice little regression formula, and I wrote it out for you here. And focus on this one here. Ignore this. These are not the droids you're looking for. All right, so y predicted is equal to a plus bx, y plus bx. So where do we get these values? Well, x is going to be and this would be a very simple example focusing just with one predictor and only. And then we're going to use this example up here. But just to lay out the basics of this formula, basically x is going to be a score on a predictor variable. B is going to be one of these b coefficients here. A is the intercept, which is going to be located at the constant, and then y predicted is the result of that. All right. So that is that's the very basic formula. So this is a little bivariate formula that the beginner's formula, if you will. Now let's go ahead and apply this to this particular example. So again, I'm using the example from page 103 of the reader. Yay, 103. Just with two predictors in the model: year since PhD and number of publications. Okay, so here, there it is. Let's go ahead and elongate this formula. So essentially we have y predicted is equal to the intercept, which is a. So a is this thing. It's going to be the 201,137, the intercept value, and it's where the regression line starts with the xy in the xy graph. So what that's going to be is essentially, really quickly over here, if this is your y predicted values over here, that type of thing, and this is something dealing with your predictor values. So the regression line has to start somewhere around here, and typically it's going to start anywhere from here, which is going to be the origin, which is right where the two lines meet, anywhere from here all the way up this side. Regression lines don't start over here. They typically, or they ordinarily squares, they're always going to start somewhere along this y-axis. They can go down, they can go up, they can go wherever. Anyway, but that's the idea of the intercept. So that value is going to be something along the y-axis. So that's what the intercept is. So we have a person's score, predicted score, is a function of the intercept plus, and then it's going to be a slope value. So these things here are slopes. So or you can think of them as regression weights. So they're slopes of regression weights. And then those slopes of regression weights are multiplied against a particular value that we want to give it. So x1, we're going to call b1 is going to be year since PhD, and then times the value that we're going to give it. And b2 is going to be number of publications. So basically, this is what the slope is for number of publications, and then we multiply it by this. So here I say, use this for example. Okay, so that's for this example. Now let's go ahead and fill in the numbers of that there, and you can see that we have, here's our intercept value of 201,37.769. Where did I get that value? It comes right there. So your I's in SPSS, everything wants to go over here. So the constant, that is the intercept, okay? 201,37.769. All right, plus, and then it's going to be 479.205. That's the regression weight or the slope for year since PhD, multiplied by x1, and I haven't given that a value yet. And then plus, and it's going to be 87.833. That's where I'm pulling this from, 87.833. And then that's going to be multiplied by a value for x2. So let's take a look and see what this looks like in broader application. So a y predicted score is going to equal to that intercept value plus the 479.205, and then I'm going to give the x1 a value of 10. So I'm going to say that's 10 years. Okay, so let's say you've been working for 10 years, and basically that gets multiplied by that. And then number of publications, that's the weight or the slope, if you will. And these weights or slopes can be positive or they can be negative. Just right now they're just positive. And here we're going to say, okay, you have 10 publications. So essentially you're taking the intercept plus, and then you take the regression weight or the slope times a value for x1. and then the slope or weight for x2 times a value for x2. And I just made these values 10 just to do. I could have made this 5 and this 10, or this. I could have made this 30 years since one's PhD, and I could have made this 5, so somebody didn't publish a lot. And anyway, but the idea is to come out with okay, well, what is somebody's predicted base salary? And when we do the math on this, it ends up being 20137.769 plus 4792.05. That's that times 10 plus 878.33. So it's that times 10 is your Y predicted value, or $25,808 and about 15 cents. So if you've been working out since your PhD for 10 years and you have 10 publications based on this data, you should be earning $25,808 and about 15 cents. And that is how you apply the little regression formula in multiple regression. Yay. So there you have it, 2 tidbits on a fabulous Saturday when the beaches are open in Orange County and they're closed in Los Angeles County. And I live in Los Angeles County, so I'm not at the beach. Anyway, take care, folks, and we'll talk soon.